Today we are going to discuss about traversals of binary trees. First of all, we should know what is a binary tree, what is traversal, and what is traversal of binary tree. First one, what is binary tree? Binary tree is either empty or it consists of a node called root node together with the two binary trees, left binary tree, right binary tree. Example shown, a binary tree with three nodes. A is root node, B is left of A and C is right of A, and B is not having any children, so left of B is null, right of B is null, so it is a leaf node. Left of C is null, right of C is null, so it is a leaf node. The node which is not having any children is said to be a leaf node. A is having children, so A is a non-leaf node. That too, it is a first node. It is called root node. Trees are or binary trees are non-linear linked lists. Non-linear linked lists. It is a linked list, but it is not a linear linked list. It is a non-linear linked list. It is not in a straight line. It is a non-linear linked list. Then second one, what is traversal? Visiting the values of a data structure. For example, stack. Stack contains some values. Visiting all the values of a stack is called traversal of a stack. Suppose if we consider Q data structure, Q contains some values. Visiting all the values of Q is said to be traversal of a Q. The same fashion, visiting of values of a tree is said to be tree traversal or traversal of a binary tree. So third one is, what is traversal of binary tree? Visiting all the nodes of a binary tree. That is one of the most important operations on a binary tree is traversal. That is moving through all the nodes of a binary tree, visiting each one in turn. So we can visit all the values, but there are many ways in visiting the nodes of a binary tree. There are three valid traversal techniques. They are preorder, inorder, postorder. Preorder, inorder, postorder. What is preorder? VLR. V for visit root node. Visit root node. Then L is traverse left subtree. Traverse left subtree. And R is traverse right subtree. So if it is preorder, visit root node, traverse left subtree, traverse right subtree. Traverse left subtree in preorder. Again, left subtree also may be a tree, maybe a binary tree. So the entire left subtree may be traversed in preorder only. So if it is only having three nodes like this, a small binary tree, it is very simple initially to consider what is a traversal. So here say visit root node A, visit A, then traverse left subtree. Left subtree is having only one node, that is visit that node. Then traverse right subtree. Right subtree is having only one node, visit that. ABC. ABC is preorder traversal. Then what is in order? LVR. L means traverse left subtree in order. V visit root node, or traverse right subtree in order. So traverse left subtree in order, left side. Left side there is only one node B. Then visit root node A. Then traverse right subtree in order C. There is only one node. So BAC. BAC is in order. Then post order LRV. Traverse left subtree in post order, traverse right subtree in post order, then visit root node. So left, right, root. Left, right, root. Left is B, right is C, root is A, BCA. BCA is post order. In this way, we can visit the nodes in three different orders. One is pre-order, second one is in order, third one is post order. In pre-order traversal, the node is visited before subtrees. In inorder traversal, node is visited between subtrees. In postorder traversal, node is visited after both subtrees. In all the cases, left is visited before right. In this way, we can traverse a binary tree in three different orders: preorder, inorder, postorder. There are three traversal techniques: preorder, inorder, postorder. Let me explain all these one by one in detail. Preorder traversal VLR, visit root node, traverse left subtree in preorder, traverse right subtree in preorder. Left binary tree and right binary tree also should be traversed in preorder only. Now we will take an example, the same example for all preorder, inorder, postorder. So what is the algorithm or what is the steps? Steps for preorder traversal VLR. Visit root node, traverse left subtree in preorder, traverse right subtree in preorder. To traverse a non-empty binary tree in preorder, we perform the following three operations. What are the three operations? Visit root node, traverse left subtree in preorder, traverse right subtree in preorder. Say we are considering only preorder traversal. This is the binary tree. It is having some nodes. A is root node, and there is a left binary tree. This is the left binary tree, and this is right binary tree. So A is root node. This is left binary tree, and this is right binary tree. What is the first step? Visit root node A. Visit root node means display A. Then traverse left subtree in preorder. So left is again a binary tree. There are three nodes. Again, we need to traverse the left binary tree in preorder. Preorder means again visit root node, traverse left subtree in preorder, traverse right subtree in preorder. That is BDE. BDE. Then third step, traverse right subtree in preorder. What is right? Right, there are three nodes. So we are going to traverse the right subtree in preorder. Preorder means visit root node C, then left, then right. CFG. CFG. So A, B, D, E, CFG is the preorder traversal. A, B, D, E, CFG. Then let us consider inorder traversal. Traverse left binary tree in inorder, visit root node, traverse right binary tree in inorder. Then to traverse a non-empty binary tree in inorder, we perform the following three operations. What are the three operations? Traverse the left subtree in inorder. So there is a left subtree. This left subtree we are going to traverse in inorder. Then visit root node. Then traverse right subtree in inorder. So this is a binary tree where A is root node. There is a left subtree. There is a right subtree. So traverse left subtree in inorder. Left subtree means BDE. That too, it should be traversed in order. In order means left, root, right. DBE. DBE. Then main root A. Left is over, root is over, then right. Right side also we have to traverse in order. FCG. Left, root, right. DBE, A, FCG. So in order traversal. Then traverse the binary tree in post order traversal. LRV. Traverse left subtree in post order, traverse right subtree in post order, then visit root node. So the left subtree has to be traversed first, then right subtree has to be traversed in first, second, then root node has to be displayed. So left subtree is having three values. So these three values has to be visited in post order. So left, right, root. D E B. D E B. Then traverse right subtree in post order. Post order means left, right, root. F G C. F G C. Then root node A. D E B F G C. D E B F G C A. Post order. In this way, we can traverse a binary tree in order, pre-order, and post order. Then traversal of a binary tree with another example. So this is another example where it contains some number of nodes. A is root node, B is left node, C is right node. B is again a binary tree, sub-binary tree, or a subtree. It is a binary tree. So B is having left child and B is having right child, but C is not having any left child. C is having null value as its left value, null value as its right value. C is a leaf node, D is a leaf node, E is a leaf node. Now we wanted to traverse this binary tree in preorder, inorder, postorder. Preorder, VLR, visit root node, traverse left subtree in preorder, traverse right subtree in preorder. Visit root node. A, A is root node. Then traverse left subtree in preorder. So in left subtree there are three nodes. We need to traverse them in preorder. Preorder means root, left, right. Root is B. So visit B. Left, traverse left subtree. Left means there is a node called D. Left of D is null, right of D is null. So D only printed. Then traverse right subtree in preorder. Again here also B, E and left is null, right is null. E, left, right. Left, right are null. So it is E only. So traverse root node, visit root node, traverse left subtree in preorder, then traverse right subtree in preorder. Right subtree, there is only one node. There is only one node. So this particular node also we consider as a binary tree. That too it has to be traversed in preorder. Preorder means visit root node. Then traverse left subtree, there are no nodes. Then traverse right subtree, there are no nodes. A, B, D, E, C. A, B, D, E, C is preorder. Suppose if I wanted to traverse it in order traversal. In-order traverse means traverse left subtree in order, visit root node, traverse right subtree in order. So here this is a binary tree where it is having a left binary tree and it is having a right binary tree. Traverse left subtree in order. So left subtree. So this is the left subtree. In the left subtree again there are three nodes: root node, left node, right node. So in order means left, root, right. D, B, E. D, B, E. Left side is over. Then root node. Visit root node A. Then traverse right subtree. Right subtree in order. There is only one node. Left is null, right is null. So C only printed. D, B, E, A, C is in order traversal. Then post order. Post order means L or V. Traverse left subtree in post order. Traverse right subtree in post order. Then visit root node. Here there is a root, left subtree, right subtree. So traverse left subtree in post order. Post order means left, right, root. D, E, B. D, E, B. Then right subtree. Traverse right subtree in post order. There is only one node. There is only one node. Left is null, right is null. So there is only one node. See, that node will be displayed. Then left is over, right is over. Then root node A. DEBCA is post order traversal. So in this way, we can traverse a binary tree in pre-order, in-order, post-order. Let me example. So this is another example where it contains some nodes having numeric values. So here, a node with information 10 is a root node and it is having a left binary tree and it is having a right binary tree. So this is left binary tree and this is right binary tree. Pre-order traversal VLR. Visit root node. L means traverse left binary tree in pre-order. R means traverse right binary tree in pre-order. So visit root node. Root is 10. 10. Then traverse left binary tree in pre-order. Pre-order means again, so this binary tree is going to be traversed in pre-order. Preorder is visit root node 6, then left value 4, then right value 8. Root is over, left is over, then right. Right is also again a binary subtree. So here again we wanted to traverse it in pre-order. Route left, right. Route is 20, left is 15, right is 30. So this is pre-order traversal of a binary tree. Suppose if I wanted to traverse it in in-order traversal. So in-order traversal means the definition is LVR. Traverse left subtree, then visit root node, then traverse right subtree. So left subtree. Left subtree I need to traverse in order. In order means the root node has to be visited in between left and right. So left is 4, then root node 6, then right node 8. 4, 6, 8. Then root node is 10. Then right subtree. Right subtree we need to traverse in again in order. So in order traversal there are 3 nodes, root, left, right. So left, root, right. Left, root, right. Left is 15, root is 20, right is 30. Then post-order traversal. Post-order travels means LRV. Traverse left subtree in post-order, traverse right subtree in post-order, then visit root node. So here there is a left subtree, there is a right subtree, then root node. So left has to be visited first, then right has to be visited next. After that root has to be visited. Again in left subtree, left right root 4, 8, 6. 4, 8, 6. Then right subtree. Right subtree in post order 15, 30, 20. 15, 30, 20. Then root node 10. In all the three cases, in pre-order, in-order, post-order, left is visited before right. And if it is a numeric binary tree or a binary search tree, the in-order traversal gives you sorting order 4, 6, 8, 10, 15, 20, 30. In ascending order, we are getting the values displayed or visited. Then traversal of a binary tree with another example. So here there is a binary tree. A is root node. A is having a left binary tree and A is having a right binary tree. So left, right. Pre-order, in-order, post-order. Pre-order means visit root node, traverse a left subtree in pre-order, traverse a right subtree in pre-order. So let me explain pre-order traversal A. Visit A. Then traverse left subtree in pre-order. So left subtree B, D, G. But B is root node, D is its left value, and G is left right of D. So here again I wanted to traverse that in pre-order. So pre-order means visit root node B. Then traverse left subtree in pre-order. Traverse left subtree in pre-order means then again visit next root D. Then there is no left, G is there. G. Then traverse right subtree. Traverse right subtree in pre-order. So right subtree C. C is root node. Then left E. Then E is having a left value H. E is having a right value I. Then F. A B D G C E H I F. So is pre-order traversal. Suppose I wanted to perform it in order traversal. In order means traverse left subtree in order, visit root node, traverse right subtree in order. First traverse left subtree, then print root value, then traverse right subtree in order. So this left subtree has to be performed in order. Again in order, left subtree of B. So left of B is null. So DG, DG, then B. There are no nodes in the right subtree of B. So B, then A, then right of A. Right of A again in order. Right of A is in order. In order means left, then root right. Left is H E I, H E I, then C F. CF. So this is in order traversal D G B A H EICF. Then post-order traversal. Post-order traversal means LRV. Traverse left subtree in post-order, traverse right subtree in post-order, and visit root node. Left subtree in post-order. Left, right, root. Left, right, root. There is no left. Right is there, root is there. G, D. Then left is over, right is null node, root node. B. Then right subtree. Right subtree means left, right, root, or left. HIE, HIE, then F, then C, then A. So GDB, HIE, FCA. So in this way, we can traverse a binary tree, any binary tree, in all the three orders: pre-order, in-order, post-order. Pre-order means visit root node, traverse left subtree in pre-order, traverse right subtree in pre-order. In-order means traverse left subtree in in-order, visit root node, traverse right subtree in in-order. Post-order means traverse left subtree in post-order, traverse right subtree in post-order, then visit root node. Implementation of a binary tree node. Binary tree is a non-linear linked list. Non-linear linked list. It is collection of many nodes. So A is a node, B is a node, C is a node, D is a node, E is a node, F is a node, G is a node. Every node contains two links, left link, right link. B is also having left link, right link, etc. Every node contains a left link, right link. So a node can be just like a node in a doubly linked list, but doubly linked list is a linear linked list. Doubly linked list is a linear linked list, but binary tree is a non-linear linked list. We can declare a node with a value and a left pointer and a right pointer. In doubly linked list also, a node is declared as a structure consisting of a value and a left pointer and a right pointer. Here also, we declare a node in C as a structure consisting of three fields or three members data of the node. Then address of left node, address of right node. See here, A is a node, it is having left subtree and it is having a right subtree. A is pointing to its left subtree, A is pointing to its right subtree. So A should have left pointer and right pointer. And B is a node. It should have some value and it is pointing to its left subtree and it is pointing to its right subtree. Where D is a node which is having again two pointers, but both left and right are null. Left pointer is null, right pointer is null. So every node contains some data and a pointer to its left subtree and a pointer to its right subtree. So a node of a binary tree can be declared as a struct node. It is having three members: data, left, right. Data is value, say A, B, C, D, E, whatever we are giving the value of the node, which is nothing but data of the node. Then what is left and right? Left is an address, right is an address. It is pointers. Left is a pointer, right is a pointer. A pointer, what is a pointer? Pointer is a variable which holds address of another variable. What type of variable? Again, it is a struct node. It is pointing to another node. It is pointing to another node. A left is pointing to B. A right is pointing to C. B left is pointing to D. B right is pointing to E. Where D, E are again nodes. So all are nodes. Every node contains some value and every node is pointing to its left subtree and its right subtree. So every node should contain a value and its a left pointer and its a right pointer. Left pointer pointing to left subtree, right pointer pointing to right subtree. So in C, a binary tree node can be declared as a structure which contains three members. Three members. These three members are: first one is data, left to right are pointers. Pointer to struct node, same kind of nodes. Then instead of using two words, we can redefine struct node as tree node. From here onwards, we can declare a variable with just a tree node, where tree node is struct node. So here the variable declaration of a binary tree, tree node asterisk root. Root is your binary tree. Its type is tree node. What is tree node? Struct node. What is struct node? It contains three members: data, left, right. Now let me explain the algorithm or function of a preorder traversal. The definition of preorder traversal is VLR. We visit root node, then traverse left subtree in preorder, then traverse right subtree in preorder. So the definition, actual definition is to traverse a non-empty binary tree in preorder, we perform the following three operations: visit root node, traverse left subtree in preorder, traverse right subtree in preorder. So visit root node V, traverse left subtree in preorder L, traverse right subtree in preorder R, V L R. Visit root node, traverse left subtree in preorder, traverse right subtree in preorder. The function is, if it is a non-empty binary tree, see preorder, there is a function, we are inputting P. P is a tree node P, it is a binary tree. If P is not null, sorry, to traverse a non-empty binary tree, yes, if it is non-empty binary tree, we perform three things. Visit root node, print of P data, P is root node, P data will be printed. Then second step is traverse left subtree in preorder. Again, perform preorder P left. Preorder P left. We are calling the same function again. Preorder left side. So left side node or left side tree has to be displayed in preorder. Then preorder P right. So right side node root right. Root right has to be traversed in preorder. Visit root node. Traverse left subtree in preorder, traverse right subtree in preorder. We perform three things: visit root node, traverse left subtree, traverse right subtree. Visit means just displaying printf p data, preorder p left, preorder p left, p is root node, left side of p has to be traversed in preorder, preorder p right, p is root node, right side is subtree of p root, subtree of root. So subtree of root right has to be performed in preorder. So visit root node, traverse left subtree in preorder, traverse right subtree in preorder. The same. The definition is VLR. Preorder means VLR. Visit root node, traverse left subtree in preorder, traverse right subtree in preorder. See here, for example, in this particular binary tree, where A is root node, B, D, E, left subtree, C, F, G, right subtree. So the definition is VLR. VLR. Visit root node. Root node is A. Traverse left subtree in preorder. Left subtree. Preorder P left. A. After visiting A, preorder P left. Preorder P left means B. B is next root. Then again the same printf preorder will be executed. Preorder means again VLR. In this left subtree, B is root. B will be visited. Then left is D, then right is E, then traverse right subtree. Preorder P right. Preorder P right means P is A, P is A, right is C. So again PLR C F G, C F G. So in the preorder function, what we are performing? Visit root node, printf p data. P is root node. Its data is printed. It is having two nodes, left node, right node. Left node is B, right node is C. So left node traverse left subtree in preorder, then traverse right subtree in preorder. We are calling the same preorder function in recursive fashion. We are calling in recursive fashion. Preorder left subtree, then preorder right subtree. Visit root node, preorder left, preorder right. So this is, in this way we can perform preorder traversal using a recursive function. Explain Inorder traversal. For the same binary tree, I am going to traverse it in inorder. What is the definition of inorder? LVR. traverse left subtree in order, visit root node, then traverse right subtree in order. To traverse a non-empty binary tree, if it is non-empty, then we perform three things. What are these three? Traverse left subtree in order, visit root node, traverse right subtree in order. See here, the same we have written in a function. If p is not null, so in order function, in order p is tree, p is a binary tree, right? P is a binary tree, input is a binary tree. We are going to traverse the binary tree in order. So input is a binary tree. P is pointing to root node. If P is not null, if it is non-empty binary tree, yes, if it is not a non-empty binary tree, we perform three things. What is in order P left? Traverse left subtree in preorder in order, then printf P data, that is visit root node, then in order P right, traverse right subtree in order. Traverse left subtree in order, visit root node, traverse right subtree in order. See here, this is the example. A is root node, A is P, left subtree, this is left subtree, and this is right subtree. We wanted to perform LVR, LVR, everywhere LVR. So left subtree in order, visit root node, right subtree in order. So first left subtree in order. What is left subtree in order? Left, visit, right. DBE, DBE, then root node A, then right subtree in order. In order means again left, root, right. FCG, FCG, D, B, E, A, F, C, G is in order traversal. Here we perform three things. See here, as per the definition, we are writing the function. If it is non-empty binary tree, we perform three things. Traverse left subtree in order, visit root node, traverse right subtree in order. Let me explain the post-order traversal. The definition of post-order traversal is LRV. Traverse left subtree in post order, traverse right subtree in post order, then visit root node. LRV. Traverse left subtree in post order, traverse right subtree in post order, then visit root node. Say, this is the binary tree where A is root node and BD is left of binary tree and CFG is right of A. So this is right subtree. So A is root node, it is having left subtree and it is having right subtree. So to traverse this binary tree in post order, traverse left subtree in post order, then traverse right subtree in post order, then visit root node. So left subtree has to be performed in post order. So post order means left, right, root, D, E, B, D, E, B. Then traverse right subtree in post order. Again, this post order means in these three nodes, post order means F, G, C, F, G, C. Then visit root node A. So in this way, we perform our post order traversal. This we need to perform using a function or algorithm. So the definition is to traverse a non-empty binary tree in post order, we perform the following three operations. First one is traverse left subtree in post order, then traverse right subtree in post order, then visit root node. The same three instructions we are writing, implementing just like a function in C. Post order P. We wanted to perform post order traversal of a binary tree. The binary tree is P. So input is P. P is a binary tree. So this binary tree, assume that this binary tree is input of this particular binary function. This particular function. So P is a tree node which is pointing to root node. If P is not null, if it is non-empty binary tree, perform three things. Traverse post order, left subtree in post order, then traverse right subtree in post order, then visit root node. We are calling post order function for P left. P is root node. Left of P is performed in post order. Right of P is performed in post order. Then visit root node. Means these three instructions are nothing but LRV. Post order P left. Traverse left subtree in post order. Post order p write. Traverse writes up tree in post order. Then printf p data v. L or v. Traverse left subtree in post order. Traverse right subtree in post order. Then visit root node. See here. This is the example where a binary tree is given. A is root node. Say this is p. P left. P D is P left. P right. C F G is P right. Then traverse left subtree. Left subtree in post order D E B. D E B. Traverse right subtree in post order F G C. Then visit root node A. So in this way we can perform post order traversal. So there are three different traversal techniques in binary trees: preorder, inorder, post order. Preorder means root is visited before left right. Inorder means root is visited in between left and right. Post order means root is visited after left and right. In all the three cases, left is visited before right. Thank you.